for this particular question, we want to differentiate it and then state the values of x for which the derivative is 0. So differentiating, I notice that I've got the product of a few terms that have x in it, so therefore I'm going to use the product rule. I need to think about how I want to split it up. I'm going to do this one the formal way. So I'm going to say let u equal my first term. I'm going to have that being 2 lots of x plus 1 all cubed, which means that my derivative of u with respect to x is going to be, I have to use the chain rule here. So I've got 3 times 2 x plus 1. 1 off the power is a 2 times the derivative of the inside, so I've got 6 x plus 1 squared. I'm going to let v equal the second term, which is x plus 2 to the 4, and that means dv dx 4 lots of x plus 2 cubed times 1, which is just 4 lots of x plus 2 cubed. Now I need to use the chain rule, the product rule, sorry, which is if y equals u times v, then dy dx is u, which is the first term, times the derivative of the second, plus the second times the derivative of the first. Okay, let's see what this looks like. First term, derivative of the second, plus the second term, times the derivative of the first. There'll be a couple of sets of common factors here. I've got x plus 1 cubes here, and an x plus 1 squared there. And the other term I've got is x plus 2's. In fact, there's a third term here I can see. Which is a factor of 2. I can bring that out of both of those. So bringing that all together, what I've got is, if I take out a factor of 2, as well as x plus 1, I've got 3 here and 2 here, so I'll take out squared. I've also noticed that I've got x plus 2 common, and the most I can take out of that is 3. What am I left with? This 2 I've used, x plus 1 squared I've used, so I've left with an x plus 1, times the 4, and all of that I used. The second term, I used all but one of these. I've taken out a factor of 2, so I've got 3 left, and I used all of those. (4x plus 3x is 7x, 4 plus 6 is 10. So there is my final fully factorized derivative. I have to find the values of x that make this derivative equal to 0, and so to do that I just set my derivative equal to 0, and if I just write that out for you again, you'll see that this is a product of 1, 2, 3, 4 terms. If I want to make that equal to 0, then the only way this will be true is if one of these terms is equal to 0, then the whole thing becomes 0. So I've got a couple of options. The first one could be that this term is 0. The second could be that that term is 0. or the third is that the final term is 0. So just solve for x here, here, and here. And they are the three places where the derivative equals 0.